If you don't want to be recorded, you can leave. Yeah. So today's session is about data modeling with Power BI. Thanks, Soheil, for presenting in the Auckland Power BI meetup. It's no longer the audience. You can see, as you can see, we have a diverse audience from India to Australia and New Zealand. Yeah, if you have questions, you can either put in the chat or raise your hands, please. And always stay muted. And away we go. So the stage is yours, Soheil.
Yeah, thank you so much for having me. And hello, everyone. And again, thank you for joining us from all around the globe. It's really nice to have you here in this meeting or session or event or whatever. So please be aware, because I'm sharing my screen on the screen on my right, and I'm looking at some other stuff on the screen on my front, and I have another screen on the left, right? So be aware if you ask a question, perhaps Indira, if you can get the questions, and if I didn't answer the question, if I didn't notice your question, right? Indira, please let me know about the questions.
Yeah, I'll be your moderator. Thank you. Yeah.
Yeah, perfect. Okay, so today's session is about data modeling with Power BI. So before going further with the Power BI data modeling, let's start with the agenda of today's session. The first thing is that I introduce myself and say, who am I? And we will look at what is data modeling in general. What is data warehousing? What does transactional data transformation mean? And what is semantic layer? And how do all these things relate to Power BI? And then I'll aim to share some best practices and considerations that it would be great to consider while you are modeling your data with Power BI. Okay, so I'm Soheil Bakhshi. I'm originally from Iran. I'm a Microsoft MVP. I'm also a consultant, a blogger. I started my weblog in 2013. It is biinsight.com. I'm an author. In 2021, I wrote 2 books, one free ebook, which you can find the download link on my website. And I also authored a book called Expert Data Modeling with Power BI. And I'm a startup owner, Data Visioner. At Data Visioner, we create some tools on top of Power BI, something like Power BI Documenter. If you heard about it, if you haven't, you can Google it and you can learn more about it. And something like Power BI Exporter, which is a tool that appears in your external tool in Power BI desktop, and you can export all of your data model data, which is your curated data, into CSV format. It packages the whole thing into a zip file, which is kind of good. And you can get in touch through my weblog, commenting on my weblog. My website is datavisioner.com, and my LinkedIn and Twitter handle biinsightNZ. Let's see what is data modeling in general, right? So this is the words that you see on the screen are not mine. These are coming from scientists at Google, right? And they believe that data modeling is the process of creating visual representation of either a whole information system or parts of it to communicate connections between data points and structure. The goal is to illustrate the types of data used and stored within the system. Look at that, the types of data, relationships between different elements, right? and the relationships amongst these data types and the ways that the data can be grouped and organized, and its formats and attributes, right? So we can organize the data, we can group the data, we can format the data. There are relationships between the data, and so on and so forth. Doesn't that sound familiar for those who already work with Power BI? This is exactly what we're doing in Power BI, right? So we have entities, which are our tables. We have attributes, which are our table columns. We have relationships. We have data types. We can organize our data. We can say, hide this column or show that column, so on and so forth. So the next thing that I would like to touch is about what transactional databases are. Transactional databases are optimized for running production systems, everything from websites to banking, retail stores, etc., etc. These databases excel at reading and writing individual rows of data very quickly while maintaining data integrity, right? So let's think about a transaction. A transaction, the best example that I can give you from a transaction is in banking. So if I want to send money to John Doe, right? I know his bank account and I send the money via internet banking, right? So the whole thing from the starting point that I hit the send button on my mobile application till the amount appears in John Doe's account, the whole thing is a transaction, right? And the whole transaction must be committed or just ignored, right? If something happens in between, nothing must be, deducted from my account or, added to John Doe's account, right? So that is a transactional database. Transactional databases are normally, there are a lot of relationships between different tables, and the reason behind that is that we do normalize in transactional models. And why we do normalize? Because transactional databases are optimized for data entry, for insert, delete, update, right? If we want to get a good performance out of our inserts, updates, and deletes, we'd be better to normalize our database and break down a big wide table into different related tables based on certain techniques.
Soheil,
Yes,
we have a raised hand from Mike. I believe you'd like to ask a question.
sure. Mike,
Mike, you can go ahead and ask the question. I think maybe he's not able to hear properly.
Mike, your microphone is on, but I cannot hear you if you're talking.
Mike Hawk, you have a raised hand. Do you have a question?
Yes, you, Mike. Mike Hawk.
Okay, maybe you can continue, Soheil.
Okay, never mind. Let's continue. And Mike, if you do have a question, just put it in the chat. Thank you.
Yep, all good. And perfect. Okay, so let's go to the next slide. I can hear a feedback in the background. If everyone can please put your microphones on mute, that would be great. Thank you. Okay, so now what is data warehousing, right? We very, very quickly and briefly touched on the purpose of transactional data modeling, right? So in transactional data modeling, again, we are thinking about optimizing the process of insert, update, delete, right? Something like when you go to a retail store and you pick up something from the shelf and you go and pay for it, right? When the guy in the front desk, they are just scanning the barcode of that product, they are inserting a transaction into an underlying database system. Transactional database systems are not really optimized for reporting systems, right? Because they are, as I mentioned in previous slide, they are normalized, right? So they are broken into different tables with different relationships. To create a report, you have to join all of those tables back, right? And aggregate the data to be able to create a report. And normally they are really slow in reporting. So what do we do with that problem? Data warehousing is a model that we follow for data analysis and reporting purposes, right? We join all of those tables together and we create large tables, right? And we normally put the numeric values into a table which is called fact. A fact is whenever an event happens, right? So when I go to the shop and I pay for something, the fact that I paid for a product is a fact, right? And then the number that I paid for it, the dollar value, is a fact. So we can put all of those facts together into a central table, which is called fact table. Obviously, those must be business related, right? So if we are thinking about, or we are talking about a sales system, we can think about a fact sales, which includes all of our sales records, right? Coming from a or multiple transactional systems or file-based systems, something like flat files. We may have Excel, we may have MySQL, or so on and so forth, right? A fact table is surrounded by dimensions, right? The dimensions are the descriptive values that are describing the event, which is the fact. When I buy a product, the product name, the date that I bought the product, the store name, or even store location, or even the person who scanned the barcode. All of those things are dimensions that are surrounding the fact table. And those are obviously related to the fact table. Those relationships do not necessarily need to be a physical relationship if I want to talk from a relational database point of view, right? But those values, the key values and foreign keys, exist in the fact table and in the dimensions, right? If you look at this model with a fact in the middle surrounded by different dimensions, it looks like a star, right? So this is why this type of modeling is called Star Schema or dimensional modeling. Both are referring to the same thing, right? A Star Schema, as I said, is optimized for reporting and analytical purposes. Okay, so and now let's see what data transformation, what does data transformation mean? As I said, we always have multiple source systems, right? We may have SQL Server, MySQL, SharePoint lists, Excel files, you name it, JSON documents, and all those sort of things. We need a mechanism to integrate those data into a central repository, because when we have everything in a central repository, it would be much easier to deal with that data, right? this central repository is called staging, right? So imagine that we need some sort of transformation. When we move the data from source system into staging, we do not normally make any changes to the data itself, right? I mean, we do not normally aggregate or we do not change the data at all, but at the end of the day, the data types are different. Maybe we have an Excel file that has some formulas in it, and we have to take care of all of those sort of things. So we need some sort of data transformation here, right? And it is the same with any of other the data sources, right? And then we move that data, and we transform the data. We reshape the data now into a Star Schema, which lands into a data warehouse with those fact tables surrounded by dimensions, right? So those lines or pipelines, they are called ETL, right? The things that we do to transform the data, to move the data from the source system into a staging environment and dealing with the staging environment, and we are no longer dependent to the source system, right? And this is called ETL. ETL is coming from three words: extract, transform, and load. Extraction of data, when we connect to a data source and we get the data out, right? Transform the data, we change the data types, because just think about it. Let me go back one step again, and your staging area can be a totally different technology. It can be a data lake, it can be a Azure SQL database, it can be Oracle, it can be whatever, right? So we really need to transform the data, because the data types that we have in Excel, they are not necessarily exist in the staging technology, right? If just think about it, if we have a Azure SQL database, we are reading data from Excel files and SharePoint lists and MySQL and SQL Server, and we are integrating those tables or data of tables into a single database or a repository of databases, right? And then, so it is good practice to have a staging system, a staging environment here, and then we are no longer dependent to the source system while we are doing our data warehousing. So any questions so far around data transformation, data warehousing, transactional systems?
Question.
I've got a question, Soheil.
Yep.
And you've got two ELTs stages. Does that affect the data in any way along the way? Once, for example, you got MySQL and it comes out of there, you ELT it, you put it into staging, and then you join something else as well. You've got that data together, but if you ELT it again, why would you want to do it a second time?
Yep. As I said, we do not. Well, first of all, this is a typo. I wanted to write ETL, not ELT, right? But ELT is legit terminology. But anyways, when we move the data from the data sources, it is coming with its original shape. We do not change anything, right? And as we all know, the data sources are not always coming with a really good data quality, and data quality is one of those things, right? Something like, maybe we have some column names that are not user friendly. We have to rename those columns. And as I said, the data types can be different, and we have to change those data types. But the data itself, we do not change anything. We move everything as is into staging environment, right? So in a staging environment, we have a lot of tables, and we identify all the relationships, and then we really require to transform that data into a Star Schema when we want to move it into data warehouse environment. Did that answer your question?
Yeah, just that last sentence did. Thank you very much.
Yeah, no worries.
Soheil, there is one more question in the chat.
Sure.
Where is the best location to transform the data, closer to the source or destination?
Well, it depends. Maybe you have multiple source systems sitting around, around globe, wherever they are. Maybe you have some on-premises environment, and maybe you have your data warehouse on premises, right? So it depends. It depends on case by case. It can be different, right? But for me, the rule of thumb is that if I am connecting to on-premises system and my data warehouse sits in Azure, I would lean more towards an Azure staging system, right? Or even a single database. There are a lot of factors that you have to think about, something like cost, right? The cost associated with the whole thing, ETL and staging and data warehousing can affect your architecture. Did that answer your question? Right?
Yeah, there's no name. I think guest. Yeah, okay. Yeah.
Okay.
He said yes, thanks. Yeah.
Cool. Okay, so, and what is a semantic layer, right? So again, we read the data from source system with some ETL pipelines. We move everything as is, unchanged in terms of data into staging area, and then we transform that data, we reshape it, and we put it into a data warehouse, right? And then there is another layer on top of the data warehouse, right? Which is optimized for reporting, right? And again, for analytical purposes. But the color of each block shows the level of trust in data, right? A semantic layer is normally gold-plated data, right? So it is in its best shape. The data is pre-aggregated, right? So just think about it. If we have, a table of 500 billion rows, then having a aggregating on a data warehouse can be super expensive. While we can pre-aggregate all of that data into our semantic layer, which is gold-plated data, and we can just have it there. It is our queries would run much faster, and we really may not need that much of history, right? You may have a data warehouse for containing 20 years of history of data, but maybe the business only requires the last 10 years of data, right? And that last 10 years of data, the window is moving, right? So we are in 2022 now, right? So it moves back to 2012, right? And next year, that window of data moves across, right? And yeah, the data can roll over time. Pre-calculated and pre-aggregated data is available in the semantic layer, and it is optimized for reporting and analytical purposes, right? So the color, again, the color of block shows the level of trust: bronze, silver, and gold, right? In some cases, you really require to create some operational reports on top of your data. And in those cases, you really need to hit the staging environment, right? But with that in mind, that, hey, look, the quality of data can be very low, right? So this is a bronze-plated data environment. So you can think about all the complexities, data quality that you will get involved with, and all those sort of things. So you have that in mind, that, hey, look, the data is in bronze level, right? When you move to data warehouses are normally silver, in terms of level of trust. They are very trustworthy. The quality of data is really high. The data is audited. All the ETL processes are really, really good. But as I said, data warehouses can be really large, right? Even though there are techniques on data warehousing, and you can pre-aggregate the data in data warehouses, right? You can create aggregated tables. You can accommodate a lot of techniques, but the gold plate data sits in our semantic layer. Now let's move forward and talk about Power BI. What is Power BI, and then what all these things mean in Power BI?
Just one more question, Soheil.
Sure.
Sufyan is saying, sorry for this silly question, but what exactly do you mean by data aggregation?
Okay, so no question is a silly question. Silly is not asking a question when you have a question. Aggregating data means when you have a lot of rows of data. Again, let me move back to my previous example of a sales system, right? So a lot of people are going to their retail shops and they are buying a lot of stuff, right? Every single record sits into a table or a set of tables. Those are transactions, right? Right. So let's think about it. If I have a global retail shop, right, with more than 100 stores around the globe, right, you may have millions of rows of sales per day, right? So when we aggregate the data, we are actually summing up. If we are there are many different type of aggregations, right? So think about it. If the business wants to analyze the data, their sales data, they on month level, right? They sum up their sales data on the month level, right? So that is an aggregation, right? So we take sum of sales over month of current year, right? So that is a aggregating the data. Is that clear now?
Sufyan, you can respond. Yes, yeah.
Okay, cool.
Thank you.
So Power BI, yeah, I always repeat this. Power BI is not a reporting tool only. There are a lot of people that when they talk about Power BI, they are referring to data visualization power of Power BI. Whenever they talk about Power BI, they say, oh yes, I saw all of those beautiful charts, but the reality is different. Let's see what the reality is. Power BI is actually a business application platform, a part of Power Platform offering from Microsoft. It includes SaaS application, which is your Power BI service. It includes local servers, something like your Power BI report server, and desktop applications, something like Power BI Desktop, which I bet everyone in this call is aware of, something like your report builder for creating paginated reports, and mobile report builder, which is a completely different tool. All those sort of desktop applications can work with Power BI platform. Every single layer has different capabilities. Something like you can do data preparation with data flows. You can visualize your data. You can run governance, advanced AI and ML, real-time data streaming, collaborating over your data on the SaaS application, which is your Power BI service. On your local server, you have the capability of consuming Power BI reports, which are built in Power BI Desktop RS, which is optimized for report server, mobile reports, and also governance. Or data preparation in Power BI Desktop as a desktop application. you can prepare your data, you can model the data, and you can visualize the data. And every single one of those has its own characteristics, something like you can connect to multiple data sources, you can cleanse the data, and you can transform the data and keep it safe in an environment with data flows in Power BI service. You can visualize your data, you can create reports and dashboards and so on and so forth. You can governance, you can monitor your tenant, your Power BI environment. You can administrate your tenant, and you can use information protection systems. You can manage permissions on it, or in governance for a report server, you can monitor, administer, and managing permissions on report server. And in Power BI desktop, again, you can connect to multiple data sources, you can cleanse the data, you can take data transformation steps, you can analyze the data in the data modeling, you can run security, something like row level security or object level security, and yes, you can build reports and data visualization, right? From a Power BI development perspective, those boxes that are highlighted in yellow are related to data modeling, right? So whenever we talk about data modeling, we may include data flows environment. So it really depends on your architecture. You may include data flow development. You may include report server reports. You may include just in you may do all your data modeling in Power BI desktop, which you prepare the data and you model the data in Power BI desktop. So I see a question. What's the question? Just disappeared from the page. Let me see if I can find a question. What are some good sources to find data work with? I want to practice using Power BI. Oh, you can just Google it. And okay, so one of the very famous data sources for training is AdventureWorks from Microsoft, and the other one is Worldwide Importers. If you Google for AdventureWorks samples, they have AdventureWorks sales, I think. Indra, am I right? I think they have AdventureWorks sales in Power BI.
There is one called Worldwide Importers, and there is another one called AdventureWorks. And there is I just posted a link to Kaggle, where there are a lot of data sets that you can utilize.
Yeah, thank you. And there is another one, Contoso, which is everyone knows about AdventureWorks and Contoso. Anyways, so
Hale,
yes,
that diagram you just showed is one of the best ones I've seen, and the fact that you highlighted data modeling and putting in that right-hand column explains it so explicitly. Thank you.
You're welcome. Thank you for your feedback. Cool. Data modeling with Power BI. Again, if we are talking about Power BI and we say it is a platform, right? And the name of Power BI is coming from business. The BI is coming from business intelligence, right? And the thing that I showed in my previous slides, when we move the data from the source system, we integrate that data into staging environment and we build a data warehouse. And then we connect to that data warehouse from a semantic layer. The whole thing creates a business intelligence solution, right? So Power BI is actually a business intelligence environment or platform, right? From here onwards, we talk about Power BI data modeling only, right? So we, again, we connect to many different data sources. We can connect to a data source and from Power BI service, which is the SaaS application of Power BI, right? And we can also connect to the data sources from Power BI desktop. This method this one is the preferred method. It is best practice not to create your models directly in Power BI service, because someone else may overwrite it. Maybe you create something in the future in Power BI desktop and you overwrite that file and those sort of things. But this capability is there for you if you would like to use. So in Power BI service, but you can create data flows, right? So you can build, it is more or less referred to as data marts, right? So if you think about a sales system, you can create a sales data mart with data flows in Power BI service, and data flows are not available in Power BI desktop as such, right? But the data flows are actually Power Query online, right? So the data flow itself has its own characteristics, but on the underlying technology is Power Query, right? We have Power Query in Power BI desktop, and we can connect to a data flow from Power BI desktop and get the data. So something like this, is legit, right? So we can connect to different data flows from Power BI desktop, and we can get the curated data, right? While we took care of all the data transformation, data mashup thingy in here in the cloud, and we store the data in the cloud as well, and we can connect to it from Power BI desktop, and we model that data in Power BI desktop, right? The preferred method, data flows, let's put the data flows aside. The preferred method is to use Power BI desktop for data modeling purposes, right? And obviously we can, again, visualize our data in Power BI desktop. We can, after we create our data model in Power BI desktop, we can publish the model into Power BI service. As soon as we publish our model into Power BI service, this blue box will turn to a data set, right? So our whole data transformation in Power Query and the data model will be encapsulated into data sets. Again, we can connect from Power BI desktop to an existing data set in Power BI service. Any questions about this diagram?
I got a question, Soheil.
Yes,
Are
sure.
you going to touch base on the concept which you just mentioned, connecting to the data sets from the Power BI desktop? Are you going to touch base in this presentation, or you're going to stop here and we're going to move in a different direction? Because my question is related to the transformation, or probably what happens when you have a data set which is a source of a truth. So this is what we are trying to establish here. I work for a government agency, Department of Health here in Melbourne. So we're trying to establish a source of truth. So we have the data sets which says this is ED, this is blah, this is mid. And then someone want to actually come and do a little transformation. So I'm talking about dark query over the data sets. We are facing few issues here. So I would like to know what are the best practices to when an end user want its own ETL over top of your data sets. Is it something possible? Is it in a pipeline? Or is it feasible, or it's not feasible at this stage? Or is there any best practices around it? So that's my question. And hopefully in your rest of your presentation, you might touch on it. Or if not, then you can answer that question later.
Yeah, no, it's not included in this presentation, but every single scenario is different, right? It really depends on your first of all, I would ask, what is your licensing plan? Do you have premium capacity or premium per user or not?
Maybe your top premium, yeah.
And what is your definition of the end user? the end users normally do not touch the data model or data transformation at all. They just see the reports. They are business users and they just use the reports. They may build their own reports, but they don't do anything on the data modeling side of things, right? Data modeling can be something very technical, right? If they have the technical knowledge, then the second question would be, why don't you use data flows rather than creating a data set? Because if you think about, let me just move back into some slides back. Oh, come on, this is a big slide. Oh, yeah, that one. Look, a data set is actually your semantic layer, right? So it is your curated data, your gold plate. A lot of organizations have many different data sets. It really depends on the business. You may like to have many different data sets, or you may come up with a just one data set for everything, which is your semantic layer, your single semantic layer, right? And the size of data set, the size of data that you are handling, you are piping within your data flows is also a factor. There are a lot of factors that you have to consider. Hopefully that helps. I don't know if it helps or not, but it just quickly answering that question without having a lot of information about the system. The general answer is it depends, and it depends on all of those bullet points that I already named. Let's move forward to the next part. Oh, you're welcome. And thanks for your question. So there are layers, different layers in Power BI Desktop, right? And now I'm focusing on Power BI Desktop side of things, right? In Power BI Desktop, we have 3 different layers, right? We have our data preparation layer, which is our Power Query or M layer, which we connect to the data sources, we cleanse the data, we, data wrangling, all of those sort of things happen in Power Query. We change the form of data types, those sort of things. And then we model our data in the data model layer. We use Power Query language for data preparation, and we use DAX language in our data modeling. And then we have our data visualization layer, which we build our reports on top of the data model. And the process of data modeling with Power BI normally starts with conducting discovery sessions with the business, right? So you sit with the business and ask for their requirements. It is discovery sessions by itself can be pretty challenging because normally the people that we are talking to, the majority of them, they don't know what they want. Actually, they want everything. When you ask them, what do you want? They say, we want everything. So what do you want is a wrong question to ask, right? So one of the outcomes of the discovery sessions, so you have multiple discovery sessions. One of it is, so one good question is to ask about their data sources. What data you are consuming right at the moment. So are we dealing with Excel files? Are we dealing with SharePoint lists? Are we dealing with a SQL Server? What are our data sources? And the next thing is we start building our solution, and we connect to the data sources. Then we prepare the data, we transform the data using Power Query layer, and then we model the data in Power BI Desktop. We aim to follow Star Schema methodology in Power BI. And with test the solution, we normally create very simple visuals or charts, something like tables or matrices. Or those two are something that I use quite a lot for testing purposes. And then we deliver the first round or first iteration of the tool to the business. Then they have to go and test, right? While they are testing, we start again. We conduct the discovery sessions. We talk about, are all the data sources included in this solution, or we just started to get 2 or 3 of them, and we may have 10 data sources or even more, right? But all of these things are surrounded, are surrounding based around the business requirements. What we would like to get out of this is business requirements, right? When we get the business requirements right, we are going to build a good data model. Without good understanding of the business model or business requirements, sorry, we cannot build an efficient data model, right? So business requirements is hand-to-hand with data modeling. And surprise, surprise, business requirements change a lot, right? Okay, so stop talking. Let's go to my first demo, which is understanding business requirements is the key. Any questions you have, you can ask, please ask while I open my first Power BI file.
No questions in the chat, Soheil.
Cool. Okay, so do you see, is it big enough or too small, or is the size okay, Indra?
If you can just increase a little bit, it'll be good.
Okay, cool. Where's the font options? Heading font size, yeah, global font size. Is it better now? Cool.
Yeah, should be good. Yeah.
Yeah. Okay, cool. Let's have a look at this. First of all, we have a data model. I have just an internet sales and product. Just don't look at this table now. I'll get there in a second, right? So I have an internet sales and a product. The internet sales table and product are related via product key, right? So I have all the descriptive values about a product in my product table, and everything related to a sales in my, or internet sales in my internet sales table, right? And I remember someone asked about test data. This is built on top of AdventureWorks test data for Microsoft, right? And the business would like to know about their average product standard costs, right? If we move to this, on the left-hand side of Power BI Desktop, we have 3 different views. So we have the data model view, the data view, and the report view, right? So I'll go to the data view, and if I look at my internet sales, I have product standard costs column in my internet sales table. And as you can see, for every single product, I have an associated product standard cost, right? So one way to calculate the average product standard cost is to write a very, very simple calculation, right? Using the average function. We say, get the average of product standard costs values from the internet sales table, right? Now, when we look at this, we can see that every single product has an associated product standard cost to it, right? When we go to the business, they say, oh, actually, those numbers do not look right. And now we should ask, okay, so how do you calculate the product standard costs, right? I have done some transformations in the background, and I have my product standard cost column in my table here. Is that the way that you calculate your product costs? They may say, no, actually, we use a flat rate for our products, not for every single transaction, right? It's per product, right? And now you may come up with a different approach, which is this kind of calculation. If you compare this one with this one, the second approach is more complex and the numbers are different, right? But what the business actually wanted is this one, right? So now what we do, am I happy to move forward with this one? Let's have a look at this measure and see what we're doing here. We are using an average X function, which accepts a table as its first operand, right? And I say, from the internet sales table, get the product keys and also product standard costs, right? And over that, calculate the average of product standard costs, right? That is an average. This by itself is a table, right? This is in Power BI terminology called a virtual table. Do we have a table like with just two columns, right? With product key and product standard cost in our data model? No, we don't. We don't have it, right? So this is a virtual table which loads into memory for the duration that this specific DAX measure is running, and it calculates the average product costs, and then it disappears, right, from memory, right? So if we want to see the values of that, what I can do, and this comes, let's come now, it is time to go back to this table that I said, forget about it for now. We can actually use that summarize part to have the table values, right? And look, this is still a very simple equation, right? Maybe the business comes back and says, oh, actually, we get the last product cost as the flat rate for a product cost. Then it would be a different situation. We have to calculate the very last product cost for every single product and then calculate it back into our measure. Again, that's a question. Is this a very good approach? No, it is not, right? If that's the case, that every single product has its own product standard cost, it would be better to move it into our product table, right? If we have this column in here with a very simple DAX measure using average, we can calculate the product standard cost, right? So this is how the business requirement changes can affect your data model, right? And it can affect the performance. If you think about, you are running this measure on top of, let's say, 20 million rows loaded into your Power BI desktop, then the performance would not be that good, right? While if you have that column in your product table, it's a totally different story, right? Any questions so far? No questions at all?
No questions in the chat, yeah.
Okay, cool. So that was my first demo. Let's move forward. Okay, so considerations and best practices. So the first best practice or consideration is try to get the business requirements right. I believe it dictates everything, right? Okay, so get data considerations, right? So by get data, I mean when you connect to a data source from your Power Query in Power BI Desktop. That is the very first step of building your Power BI solution, right? So where the data source or where are the data sources located? Would you need to have on-premises data gateway, right? It can change your whole architecture and scenario, performance tuning, everything, cost associated with it, right? That can be a very, very legit consideration. For file-based data sources, are we dealing with a single file or a set of single files? Which means, are we getting data from a single file per query in our Power Query layer, or are we getting the data from multiple files, which means that we have to append those files in our Power Query, right? Do we require to append the data? And the storage technology, what is the storage technology of the file-based data sources? Are they flat files, and where are they stored? Are they in the cloud? Is it the data lake? Is it, I don't know, does it include some Parquet files? Is it on-prem? Those are the things. Dealing with web APIs such as OData. Whenever we are dealing with web APIs, there is a chance that we will get in trouble with throttling. There is always a risk of throttling, right? Because there is usually a limitation on the number of rows that we can get in our queries, right? For a period of time, right? Let's say in a minute or 30 seconds or something, right? And it is best to get only the required columns. And it is not only about, well, this particular point is not only about web APIs or OData. With OData and web APIs, you feel it much more than other data sources, because other data sources are pretty fast, right? But with OData, I was doing a project about 2 weeks ago, and one single table had more than 800 columns in it, right? Whenever I was connecting from OData to that table, just one table, the specific table was throttling, because, you know, the Power Query was trying to read all of those more than 800 columns, right? So with OData, there is a capability, querying capability, that you can query the underlying database, which is exposed via API and OData, right? You can name the columns that you want. So do I need to grab all the 800 rows at my very first step, which is my source in Power Query? No, I don't. How many columns do I require? It depends on the business, but in my case, it was only 25 columns, right? So after naming those columns and getting those columns specifically, you know, the connection was super fast afterwards, right? Having Excel data sources, be aware, this is danger zone. This is danger zone. Ensure to get data from tables when possible. If your Excel file contains tables, it is best to get the data from tables, not the worksheets, right? And do not rely on the custom functions automatically created by Power Query. Whenever you get data from Excel, it creates a bunch of custom functions in Power Query. And especially if you have to combine those Excel files, and those Excel files, if the Excel files are stored in SharePoint, again, you are at risk of throttling, right? Your connection may drop after a certain interval, time period, right? Do you have, you may have formula issues in Excel. So Excel is always, in my opinion, in my humble opinion, and different people may have different ideas about it, but Excel is one of the trickiest data sources to deal with in Power BI. And do not forget to set the privacy level, especially when you are dealing with different data sources, right? So again, it depends, but I usually use the organizational level of privacy level in Power Query, right? The next part is data transformation considerations. Try to move the data transformation activities to the source system as much as possible, especially if you are dealing with a relational system, something like SQL Server or Azure SQL Database or Synapse. Try to move the transformation activities into the source system as much as possible, because it would be much faster to connect to a view or whatever, which is the data is already curated and available for you to pump into Power BI or connect to from Power BI, right? Ensure you get the data granularity right, or the summarization level. So if I go back to my sales example, if I want to analyze my sales over month, and I would like to include regional stores and who sold the product, right? The granularity would be my store name or store ID, location of the store, and product name, and month, year and month, so a date, and we aggregate the data into that level. If you want to identify the granularity of a fact table, it is best to look at the surrounding dimensions, right? So usually, well, it is not always the case. You may have some dimensions that are handled within the fact table. I'm not going through those sort of too much details, but it is usually includes your foreign key, your foreign keys of your dimensions surrounding your fact table, right? Always check with the business how much history they require, and then filter the data, right? Again, in my example, which I was dealing with an OData on top of a CRM system, right? While I got only 24 columns, right? The amount of data was piping to Power BI was too much. It was more than 10 years of data, right? And the business really didn't require that much data, right? So we put some filters in, right, into our OData query. So you can cut off the amount of data that is being loaded into Power BI to get a better performance, right? Only load necessary columns when possible and remove unnecessary columns, even though after you got your data and you have everything in Power Query, you may still not require all of that data to be loaded into your data model, right? Maybe you want some columns to take care of some calculations. You do those calculations, and at the end of the day, you can remove those columns from your table, right? Power Query is case sensitive. Be careful about that. Not only the syntax of Power Query is case sensitive, the case sensitivity, Power Query treats the data with case sensitivity, right? So if you have two GUIDs, unique identifier, right? And if one of them uses uppercase characters, the other one uses lowercase characters, when you look at it, human brain thinks those two are the same, but Power Query brain says, nah, they're not the same. So consider to use same case when you are dealing with especially different data sources. Maybe you have a GUID set in Excel and it is in uppercase, and you have the same column or similar column coming from an old data, and it is in lowercase. You join those two tables, you create the relationship, and you get nothing out of it. Why is that? Because of case sensitivity, right? You have to just transform one column to uppercase or lowercase, right? In one table, and then create the relationship. Be mindful of query folding. This is pretty interesting, topic to talk about. It, even 1 or 2 sessions may be not enough to cover everything about query folding. But query folding is the ability of translating Power Query language, and Power Query and data mashup engine takes care of it, into the native language of the data source that you are connected to. If I am connected to an Azure SQL database, right, Power Query is capable of translating our transformation steps into T-SQL, right? When it can translate it to T-SQL, it sends the query back to the server. It runs the query in the server and gets the results back, right? Those fellows that are coming from development background, especially if you are as old as I, you are familiar with server-side and client-side data processing. And when a query folds, you can think about server-side data processing. So you are sending a query to the server, and the server is taking care of the data processing, and just sends the results back to the client, right? While when a query or a step in your Power Query is not folded, it means that your data mashup engine must take care of the transformation, and maybe the amount of data that is piping is too much. So it is normally and usually much slower, right? So that is query folding. Data type considerations, right? In Power Query or data transformation in Power BI is pretty important. Always select the correct data type, right? There are some certain data types that in human eyes may look pretty similar, but they are actually different. Something like a date time zone, right? When you load the date time zone data from Power Query into your data model, the date time zone is not date time, it is text. So perhaps if you want to do some calculations on top of it, you won't be able to do that unless you turn it to date time, right? So take care of the data type conversions in Power Query layer when possible, rather than just changing the data type in your data model layer, right? And it is an interesting topic. The data types are different in Power Query and your data model. In the data model, you have DAX data types or Vertipack engine data types, while in Power Query, you have Power Query or M data types. Those are completely two different things, right? But the linkage between the two, Power BI does some magics in the background, and it translates a data type to another, right? So avoid date time zone when possible. Again, because it translates to text, it turns to text, right? And text doesn't compress that much. It consumes a lot of memory, right? convert decimal values to fixed decimal values when possible. So when you have a decimal value, I think it contains maybe it calculates up to 8 or 12 decimal points, right? After the decimal point, 12 numbers, while fixed decimal point is limited to only 4 digits after your decimal point, right? So it compresses much better than decimal. Include column data type within the transformation step when possible, right? I saw a lot of developers when I open up their Power Query layer, I see change data type 1, change data type 2, change data type 3. There are a lot of steps to change data types, and if you optimize their code, you may come up with a code without any change data types whatsoever. There are some Power Query functions that are capable of turning or defining the output data type. If you are dealing with those functions, then use the optional part, which is normally the last operand, to define the data type. Include all data conversions in a single step. If you have to convert data types, do your best to include everything into just one single step. I know it is not always possible, but when possible, right? And avoid columns with data type any, right? When you do not define the data type of a column, it comes with any data type, and the data type any I will show you in a second comes with AB12 on the logo on the top left, right? So avoid that because it turns to text. And here's time for the second demo, data type conversion considerations. Any questions so far about whatever we discussed so far?
No questions in the chat, Soheil.
I don't know if it is a good sign or bad sign, Indra. Please talk to me. Ask questions.
Wake up.
Yes, exactly. Ask me some questions.
What time is it?
Oh, yes. It's time for lunch. No, just kidding.
Just teasing, but no questions. I always believe is that you're doing it right.
Okay, cool. So I prepared a very simple and ridiculous data model just to show the importance of data type conversion in Power Query and how it turns in Power BI data model, right? So let's go to our Power Query layer and see what is happening here. Right, look at that. Let me zoom in a bit. Look at that. I have the values of 100 and some integer values, some negative values, some decimal values, and some really large values in terms of SQL language. The last value in row number 7 is big int, right? Power Query is detecting all of those as type number, right? It is interesting. So everything in Power Query, easy. Every number is number, but is that the case? No, it's not. What we see here is actually the data type category. In the background, Power Query engine uses different data types, right? For every single one of those. Not for every single one of those. So these ones are integer. This one is fixed decimal. That one can be a fixed decimal or decimal. That one is also integer, and it is int64. That one, and this one is also int64, right? So that is a very simple example. And as you can see, ABC123 is type any, right? Which means you can have any values in it. It can contain text values. It can contain decimal values, numeric values, whatever, right? So the next table is containing 10 million rows, right? I generated, if I open up the advanced editor, you will see that I just generated dummy data, right? With 10 million rows of data, right? And I turned those data into different data types, right? So the first one is type any, right? ABC123. The second one is decimal. Third one is fixed decimal, which is also named currency, right? That's a facet for the data type, and percentage, right? And as you can see, well, we have 10 million rows, right? Let's see how the 10 million rows compressed when we load this data from Power Query into the data model, right? To see that, I have to go to my data tab, and look, I have 10 million rows of data, right? First of all, let me show you something. This file, this specific file with 10 million numeric values compressed into 350 megabytes of data. This is just one table loaded into the data model, 350 megabytes. And we think that, what's wrong with it? We are storing only numeric values. Let's see what is wrong with it, right? So I go to the external tools tab and I open up DAX Studio, right? And in DAX Studio, which if you are not familiar with, I would recommend reading about DAX Studio, download it. This is a free tool available for you to download and use and learn DAX and DAX language, right? So, but DAX Studio is not only about DAX language. It has really good features, something like I would like to use the VertiPack analyzer, which is now renamed to ViewMetrics. I go to ViewMetrics, actually VertiPack analyzer metrics, and it is showing me compression and a lot of metadata information about the table. Look at that. Look at that. This is really interesting. Those two columns together, the decimal values and percentage, those are consuming the most memory and space of the table, right? And this is just
one question. Can you go back and show how to get to this DAX Studio, and if they don't have the external tools, how to only then that tab will be enabled, right? So can you mention that, please? There is a question on, could you please repeat in which tab to find DAX Studio?
Oh, yes. Okay. Very, very good question. Thank you. Thanks for asking. Okay, so I am looking at this tab, which is external tool, right? And as you can see, I already have some external tools here. I have ALM Toolkit, DAX Studio, Power BI Documenter, Power BI Exporter, the Tabular Editor, the SQL Server Profiler, and Tabular Editor 3. Right? You may see some other people that they have millions of other external tools, but if you haven't installed any of those tools, you will not be able to see this specific tab, right? So I would recommend to go and install one of those tools, which will give you the external tool tab in your Power BI desktop. If you do not have the external tool, you still can use DAX Studio. You can just run it from your desktop, right? So I click on here, I have in my taskbar, you can run DAX Studio, and then you say, oh, actually, I want to connect my demo to and DAX data types, and then you connect to it, right? And from there, I go to Advanced tab to get Vertipack Analyzer, right? I'll go to Advanced tab and, oh, sorry, wrong button. And I click on the View Metrics, right? After I click on the View Metrics, I can see a lot of valuable information. It is giving me the cardinality of the file. So cardinality means how many distinct values I have, right? So I have 2 million rows and the cardinality is, 10 million rows and the cardinality is 10 million, right? So every single row is different from the other, right? So, but look at that. What is the data type? And this is where things get more interesting, right? The data type that we see here are actually Vertipack engine data types. They are DAX data types, right? But they are not something that we see in Power BI desktop UI, right? So those two are double, and the double data type take a lot of memory, as you can see here, those two. So percentage. If you want to use percentage data type, think twice. Decimal is the same, right? If you are dealing with a huge amount of data, I would recommend to discuss with the business how many decimal points they would require in their analysis, right? If 4 decimal points is enough, then definitely go for fixed decimal point. The drawback for this is that your column and your measure will come with a $sign in the string formatting that you can change it. You can say, I don't want currency. It is not currency. It is actually just a decimal value, right? And as you can see, just look at that. I have 10 million rows, but for this one, which is fixed decimal point to 4 decimal points, my cardinality is only 100,000 out of 10 million rows, which means when a Vertipack engine compresses this information, look at the compression. Let's talk on top of facts, right? Okay, so look at that. That consumes 0.18% of the volume of table, right? So I hope I gave you the message of how important it is to get the correct data type in your Power BI data modeling. Any other questions about data type conversion and data types in general in Power Query, DAX, something? Nothing. Okay, so I'll move forward with the last part of my presentation, which is data modeling considerations, right? Data modeling considerations. Okay, so use a bridge table to implement many-to-many relationships. There is a bidirectional relationship availability in Power BI and many-to-many relationship availability in Power BI, right? It is best to avoid those two, right? Unfortunately, I do not have any graphical representation here to show you what it looks like, but let me just do something. Let me just quickly check the clock. Okay, so we are good. So let's say I have table 1, table 2, and table 3, right? If table 1 and table 2 are related in a many-to-many relationship, it means any row from table 1 relates to many rows in table 2 and vice versa. So any rows from table 2 relates to many rows in table 1, right? Okay, so now let's add another table to the equation. My table 3 has a one-to-many relationship, or let's say just to one of them, right? Not that one, right? It has a one-to-many relationship with table 2, right? Now, every single row of table 3 has a relationship with many rows on table 2, which every single of those many rows on table 2 has many relationship or has a relationship to many rows in table 1. Even explaining it is pretty confusing, right? So I can go through that path from table 3 to table 2 to table 1, right? So it elevates the level of complexity of your data model, right? Visually, it may look very easy to understand to have a many-to-many relationship here in between two tables. But what happens in Vertipack engine in the background, it is so complex, right? And just think about it. You don't usually have only 3 tables. You may have 2, 3, 4, 5 tables, and those tables will have relationships to each other, right? Every single row of those that has a relationship to table 1 or table 2 will be related to both tables, to many rows of both tables, right? Okay. With that, let's go to the next one. So avoid bidirectional relationships. Bidirectional relationships, every relationship in Power BI, when you see the relationships, there is an arrow on the relationship which shows the flow of filtering of data, right? When I have a, maybe it is best to open my demo right now and just move it here. Okay, so if I go to my model tab, look, that is a relationship, right? And that little thingy, that little arrow is showing the direction of filtering. So this table, date table, is capable of filtering internet sales table. And as you can see, I have 2 inactive relationships. We'll get there in a second, right? So if I put a filter on this table and I say, just give me the rows of year equal to 2022, that filter propagates down through that relationship to the internet sales table, and it filters all the rows for year 2022. All right, does that make sense? Cool. The next one. Avoid calculated columns when possible, right? Use Power Query instead. So I go one step further or one step back. Not only use Power Query, again, push it to the data source when possible, right? If it is possible, push it to the source system. If you are using Azure SQL database or a on-premises SQL server, just add that column to the view that you're connecting to, right? Otherwise, next priority, handle it in Power Query. And the third priority, okay, so if you have no other choices, then go for it. Create calculated columns. The reason that we say it's better to not to use calculated columns is that calculated columns load into memory from the moment that you open up your Power BI desktop file on your machine, or you open a report in Power BI service. It consumes memory from the very first moment that the table containing this calculated column loads, right? The way that Power BI works is that whenever you use a column or a measure in a visual, it loads it into the memory, right? It has a sort of cold cache hard hot cache or warm cache mechanism, right? But with calculated columns, those values, the calculated column sticks to memory unless you close the file, right? And they do not compress that well because the whole table must be loaded first, and then the calculated column will be calculated and loaded into the memory, right? Disable auto date time functionality, right? We'll get there in my demo in a second. Mark your date table as date. You always would like to analyze the data over date or time or both, right? If you are analyzing your data over date, there is a feature in Power BI and in SQL in Analysis Services Tabular or Azure Analysis Services to mark the date table as date. With that feature, you tell the Vertipack engine that, hey, look, this is my date table. Treat it as a date table, not as a usual or regular table, right? And we will see that in a second. Use aggregations. If you are dealing with a big amount of data, try to implement aggregations in your data model. Implement incremental data refresh on large tables. If you are again dealing with a large table, it is best to load the data incrementally. The way that Power BI works is whenever you hit the refresh button in Power BI desktop or whenever you refresh the data in Power BI service, it just truncates the whole table and reloads everything from scratch, right? So how cool it would be if we can detect the changes and only load the changes. It is really feasible and it is actually best practice. And in some cases, this is the only choice we have if we are dealing with really large amounts of data to implement incremental data refresh, which we identify the changes and only load those records of data that has changed since previous data refresh. Avoid unnecessary snowflakes when possible. And this is related to a Star Schema, right? So if you have, I don't know, if you have 3 different dimensions, something like product category and product subcategory, which I'm referring to AdventureWorks, right? It is like that in AdventureWorks. It is best to combine those 3 tables into just one dimension rather than having 3 different tables with relationships, right? Relationships come with cost. Use Vertipack Analyzer in DAX Studio to better understand how your data model performs, which was our previous demo, right? And always create explicit measures. Whenever we use Power BI, we can create 2 types of measures. We can have implicit measures or explicit measures. Let's see what is an implicit measure or an explicit measure, right? So let me go to my previous demo file, which is this one, right? So if I go there and I put a table on the report canvas, what I do, I say grab source. Oh, actually, this is loading 10 millions of rows. Maybe grab that, right? What happens here, Power BI is actually creating a measure, a summation of the column that I selected, and it puts it in the visual, right? That measure is encapsulated within this visual, and it is not visible to any other parts of my report, right? So it is not reusable, right? This is an implicit measure. Whenever you see this sigma sign, which means that the column is actually a numeric value, contains numeric value, right? You can click on it or drag and drop it and put it on a visual, and it generates an implicit measure for you, right? Stop doing that. That's not good practice. Instead, create explicit measures. The explicit measures are those ones that you write by hand, or you use, I don't know, you right click and you use a quick measure feature, which is kind of a cool feature to have because you can learn a lot from it, right? So now let's go to the third demo, which I already opened. Demo 1, 2, 3. Okay, so I have a couple of best practices here, right? So in active relationships, it is best to active the inactive relationships, and I just showed you previously that those are inactive relationships, right? Whenever you have multiple relationships between two tables, or you can reach two tables from two different paths, and I can show you here, right? So look at that. I can reach to customer from sales territory using two different paths, right? I can go through that path, right? Or that one, right? So Vertipack engine doesn't allow that. I know the direction of this is different, but what we can do, I can reach to, it is reaching from sales territory to internet sales table. Sorry. Just forget about it again. Okay, so I can reach from sales territory. I'm confused a bit. Okay, so, yeah. From my sales territory table to internet sales from two different paths, right? I can go from there to geography, to customer, and from customer to internet sales, right? Or I can go directly from there to there, right? This is not allowed, right? Power BI doesn't allow us to enable that relationship, or it depends on when we create the relationship. The very last one, it doesn't allow us to enable it. Disabled relationships are created, are shown by dotted lines, right? So basically it is not feasible to double click on the relationship and say make the relationship enabled, because it doesn't allow you unless you break the relationship from somewhere else. You can go and say, okay, so make that relationship inactive, and then go back and say now make this relationship active. This is not possible when we are building a solution, right? We cannot manually go there and change the relationships. Instead, there is a function in Power BI called use relationships, right? So with use relationships, we can enable the relationships between two tables, right? So here I'm saying use this relationship and enable the relationship between due date key and date key from the date table, and the other one from internet sales table, and for the duration that this specific calculation is calculated, right? So that was one best practice or consideration. And calculated columns, I just jump over it because we already discussed. Okay, so mark your date table as date. Look at that. I have created some measures here. I have my internet sales year to date. Those are my time intelligence measures, right? And month to date, internet sales last year to date, and internet sales last month to date. But look at that. My internet sales year to date values reset on the month level. Look, I moved to February. Look at that. And that is my internet sales year to date. Why is that? It must accumulate. It must continue adding the values all the way down to 30th of December of this year, and then resets at the 1st of January of next year, right? The reason, and not only that, if I scroll down, you see that those two doesn't have any values, right? The reason behind that is that I didn't mark my date table as date. So the Vertipack engine is treating this specific table as a regular table, while it is not a regular table, it is a date table, right? The remedy for that is we have two remedies, right? So if I click on that and I go to my time intelligence and I look at that, I can add this line of code here, right? I can say, consider calculating total year to date over the internet sales measure and all of date table. That is one remedy, which is not recommended. I don't like that one, right? The better option is to just right click on your date dimension or your date table, go to mark as date table and mark it as date, right? And then you have to select a column with date type, right? My full date is a date data type. It just examines the values to ensure that it is a good value. Well, it is validated, right? It validates it as a date value, right? And look at that. Everything's corrected now. So look at that. My year to date is moving forward and it is accumulating all the way to October, November, and December, and it resets on the 1st of January 2012, right? Disable auto-date time. You can disable auto-date time from the options settings. We have two options here. The first option is to disable auto-date time in here, which will disable the auto-date time for the future files that we create with Power BI Desktop. When we open up Power BI Desktop, the auto-date time feature is by default disabled, or we can go down and on the current file section under the load data, we can take that tick off and disable auto-date time from there, which disables the auto-date time for the current file. Okay, so if we don't do it, what happens? Let's see what happens, right? So to see what that auto-date time does, I can again use the external tool, and again DAX Studio. I can go to DAX Studio and look at that. There are some grade tables that are automatically generated by Power BI Desktop. Look at those. Those are private tables, private date tables. If you look at the values of those tables, preview data, look, it is saying date, year, number, month, quarter number, quarter, date, right? Starting from 1900, right? This is ridiculous, right? Why is that? It turns out that Power BI wants to be so clever, right? Which is clever. And it is actually a genius idea for those people that are not really power users, right? And they do not create a date table in the data model. So what should we do? Are we going to stop them from using time intelligence calculations? No, we create tables, hidden tables, or private tables in the background. And the way that Power BI does it, it goes all over your data model and it identifies all the date time columns, including your date table, right? That is a date time. It goes to here, and that is also a date time, and that is also a date time, and it generates a table per date time column, and it creates a relationship between the date value of the private table and the date column that you have in your data model, just to generate this sophisticated hierarchy here. Look, I did not create the order date hierarchy, but I have the hierarchy here and I can use it in my data visualization. This hierarchy, date hierarchy, is generated automatically by AutoDate time feature. If you disable it, you will lose the AutoDate time here. With AutoDate time, if you use it in your DAX statements, all of those DAX expressions will break and you need to modify those, right? So it is best to disable AutoDate time at the very first place. And with that, this is the end of my demo. And I hope you enjoyed it. You learned something from it. Thank you everyone for attending this session. I'm happy to answer any questions that you may have.
Thank you very much, Soheil. That's awesome.